Number 1, in your notes, make sure you got the formula for compound interest and continuous compound interest. So the first one is compound interest. The money you got in your bank is going to be equal to, the P is the principal, that's how much you originally deposit. You're going to multiply that by 1 plus a fraction, and then on top of the fraction is the interest rate, and then on bottom of the fraction is n, and n means how many times you compound in a year, and then raised to the exponent, and the exponent is n times t, and t is the number of years that you leave it in the bank. So your first problem, you inherit some money and you talk to your broker, he convinces you to invest it with him, and he promises you, so the first thing you know, 10 grand, that's your P. That's how much you're going to deposit in the bank. 8.5%, that is your interest rate, and that's R. But you can't type it in as a percentage, you got to type it in as a decimal, so you need to move the decimal 2 times to the left. And compounded monthly, this is your N. How many times a year are they going to pay you interest? They're going to pay you interest monthly, so 12 times a year. Now this we need to use to find the T. So you're 23 years old, and if you leave it until you retire at 65, how long is that money going to sit in the bank and collect monthly interest from you? So 65 minus 23, the number is 42. So 42 years, that money is going to sit in the bank. So here we go. A, how much money are you going to have at retirement? You are going to have 10 grand multiplied by 1 plus, okay, the interest rate, we've got to go 0.085. You got to move that decimal 2 times to the left. On bottom N is, they're going to pay us interest once a month, so 12 times a year. And then the exponent is that 12 times how many years you leave it in, and we decided we're going to leave it in for 42. So now you just type this in exactly as it is on your calculator, press enter, and it's going to spit out the amount. So I'm going to pause it and calculate it. Okay, that's going to spit out 350,724 and then 40 cents. So this is how much money you're going to have at retirement. Okay, B, we need to use a different formula. B, we need to use a continuously compounding. That means instead of paying you interest once a month, they're going to pay you interest every second, every millisecond. So you're constantly making interest. So the formula for continuous interest, the money you got is equal to how much you deposit multiplied by E raised to the R times T. So now the broker says he'll give you a better deal if you invest more money. So now you're going to invest 25 grand. He's going to give you, so that's P, he's going to give you a better rate, that's R, and he's going to compound it continuously, so every second. How much are you going to have in your account at retirement? So the time is still 42. So the money you're going to have is equal to 25,000 multiplied by, I guess there's no parentheses, times it by E raised to the 0.10. So you got to move the decimal twice, times the time, and that's 42. So let me pause and calculate that. Okay, and this is going to spit out quite a bit more money. So this is going to give you 1,667,158 and 28 cents. So make sure you get those two formulas in your notes. Okay, number 2, there's no formula. They're going to give you a formula, but 2 is you have to know how to use logarithms. So this formula is Newton's law of cooling, and you need to know the T sub S, that's the temperature of the room. T sub 0, that's the initial temperature of the object. And then T is time, and K is the cooling constant. So let's see if we can figure out what number goes to which variable. So your mom pours you a bowl of soup. It's hot. You burn your tongue. Take temperature of the soup and find it to be 185. Okay, this 185, that's the T sub 0. That's the initial temperature of the soup right off the stove. And they're going to give you this for K. So they tell you that's the cooling constant. And they want us to calculate these things. Find the temperature of the soup after 10 minutes. So that's T. This 10's going in right there for the T. And the room temperature is 70 degrees. And that is T sub S. So, the temperature of the soup is going to equal T sub S, so the room temperature, that's 70, plus the initial temperature, that's 185, subtract the room temperature, and you got to multiply that by E, raised to the negative K, so 0.0296, and you're going to multiply that by the time in minutes, so we'll do 10. And let's crunch this, type this in our calculator here, and that should be the temperature of the soup. So times E negative 0.0296 times 10. Okay, after 10 minutes, the temperature is going to cool down to 155.5 degrees. So I type this in, and that's what the calculator spits out. Okay, now B is the good problem. B is where we're going to have to use logs. So they want to know how much time goes by until it cools down to 100. So now you're going to put 100 in for the temperature. So it's going to be 100 equals 70 plus 185 minus 70 times E to the negative 0.0296. But what they want to find is this time. They don't know that. So that's the variable we want to solve for. So that's what we want to undo. So we're going to have to undo everything and get this time all by itself. So let's undo this first. Undo the 70. So let's minus 70 on this side and minus 70 on that side. So now you got 30 is equal to, okay, now 185 subtract 70. That is equal to 115 multiplied by E to the negative 0.0296 times T. So now I'm going to undo this 115. So undo the multiplication, divide by 115, divide this by 115, and 30 divided by 115. Okay, the calculator tells me it's going to be 6/23. So I'm going to erase this space and start using this space. So 6/23 is equal to E raised to negative 0.0296 T. Okay, now T, before we can get rid of this negative 0.0296 times T, we got to ditch the E. We got to ditch the base of E. So T is an exponent, E is the base, and how you undo a base is you do a logarithm. So the only way we're going to solve for T, if T is in the exponent and you want to undo this base, you've got to do a logarithm. So you just morph this into a logarithm. So it's going to be log in base E, that's my base, of 6/23, and that is equal to a negative 0.0296 t. So now I'm going to do this on my calculator. I'm going to type in log in base c. Log in base c is the same thing as ln of 6/23. So if I type in ln of 6/23, I get a negative 1.3437 equals point. I guess it's a negative 0.0296 multiplied by t. So now if you want to solve for t, undo the multiplication. Divide by a negative 0.0296. Divide this side by a negative 0.0296. And we get t is equal to 45.396 minutes. So it's going to take 45 minutes for that soup to cool down to be 100 degrees. But the big thing is how to solve for your variable when your variable is in an exponent. And the only way to do that is by using logarithms. Okay, number 3. They want to solve for x. X is in an exponent. So let's undo all this stuff. First undo the divide 2. So instead of divide 2, let's times 2 and let's times 2. And now that gives us 6 times e to the x plus 4 equals 6. So let's undo this plus 4 next. Let's minus 4 minus 4. So you got 6 multiplied e to the x equals 2. Now let's ditch the 6. Let's undo the times 6. So let's divide 6, divide 6. So we got e to the x equals 2 divided 6 is the same as 1 divided 3. Okay, now the only way to ditch the base of e is to do a logarithm. So let's do log in base e of 1/3, and that equals x. And log in base c is the same thing as the natural log ln. So you got ln of 1/3 equals x. So x equals ln of 1/3. Okay, number 4. So the properties of logs. You should use the properties of logs to expand this single log into 2 logs. So move number 1. Let's take this exponent of a 3. Let's take it to both the u and the v. So it's going to become log in base 8 of u to the 9. I times them. 3 times 3 is 9. Times v to the 3. Okay. Now multiplication, if I want to take this single log and rewrite it as 2 logs, multiplication is linked to addition. So it's going to be log in base 8 of u to the 9 plus log in base 8 of v to the 3. And then the last rule, the last property says you can take these exponents and you can move them out in front. So if you take this 9, it's going to be 9 multiplied by the log in base 8 of u plus 3 multiplied by the log in base 8 of v. And that is 2 logs that are the exact same as this one single log. And now let's go the other way around. Let's take these 2 logs and let's condense them into one single log. So let's go totally backwards. Let's take this 8 and put that as an exponent. Let's take this 4 and put that as an exponent. So it's going to be the natural log of a raised to the 8th subtract the natural log of b raised to the 4th. And now subtraction, if I want to combine these two into one, subtraction is linked with division. So it's going to be the ln of a to the 8th divided by b to the 4th. And that's as far as you can go, so that's your answer. Number 6. Okay, the sine of theta, so you gotta be careful because there's a theta here and there's a phi here, and these two look kind of similar but they're totally different. So this is marking the location of this angle. The sine is opposite over hypotenuse. So this triangle, the opposite would be right here, that's 3. The hypotenuse is this one, that's 5. And this is a Pythagorean triple. So all 3 sides are whole numbers, this side's a 4. And if you don't know that, you can do Pythagorean theorem. So Pythagorean theorem is the little side squared plus the little side squared equals the hypotenuse squared. So 9 plus x squared equals 25. Then you got a minus the 9, so you got x squared is 16. Then undo the square root. So x is 4. So that's what we got. This side's 4. Now, they want the tangent from this position right here. So the tangent is a fraction that's opposite on top and adjacent on bottom. And if we're going from this position, our triangle is just gonna be this one reflected across this hypotenuse. So the opposite is gonna be this side, which happens to be 4, and the adjacent is this side, which is equal to 3. So we should have 4/3. Number 7, solve for x. So let's get rid of the 4. Let's get rid of the 9. You gotta get x all by itself, but you gotta get rid of the 9 first. But 9 is as a base. The only way you can undo a base is if you do a logarithm. So it's going to be log in base 9 of 12 equals 4x. And then now you can solve for x, get rid of the times 4. So divide by 4. Divide by 4. So do this, change this to a number. On your calculator, type in log in base 9 of 12. Because you're not just dividing the 12 by 4, you're dividing that whole thing. If you type in log in base 9 of 12 and hit enter, that's a decimal. That decimal is like 1.1309, and that's what you're dividing by 4. So if you divide that by 4, x is equal to a decimal, and it's 0.2827. Okay, number 8. Now we're solving for x, but x is tied into a logarithm. So remember ln, that is the same thing as log in base e. So if I'm going to get rid of x, I got to get rid of this 2, I got to get rid of this log in base e, and I got to get rid of this times 3. Let's get rid of the times 3 first. Divide 3, divide 3, so that's gone. So now we just got this, log in base e of 2x equals 3. Now you can't get rid of the 2, you gotta get rid of this log. The only way to undo a log is let's morph it to a power. So if you morph it to a power, your base is e, the exponent is 3, and that's equivalent to 2x. So now I'll do this on your calculator. E cubed is 20.0855, and that's equal to 2x. So now you got to ditch the 2. So undo the times 2. So let's divide 2, divide 2. So 20.08 divided by 2. And that x is going to equal 10.0428. Okay, I think the rest of this is trig. So number 9, and we've got to draw a triangle based on this information. So the recommended angle of elevation for a ladder is 75 degrees. What height on the building does a 21-foot ladder reach? So here's my building right here. I got a 21-foot ladder. and I'm going to use exactly that angle. I'm going to use 75 degrees. So my ladder is 21 feet, and my triangle is going to be right here. So 75 degrees, say that's 75 degrees. This is where we're going from. From 75, we need to label the triangle. The 21 is actually the hypotenuse, and this is the opposite, and the base is going to be my adjacent. So what they want to know is the opposite. How high on the building is this going to go? So let's use opposite, and let's use 21, which is hypotenuse. So if you're using opposite and hypotenuse, you need to use sine. So the trig we're going to use is sine. So the sine of 75 degrees is equal to the fraction, opposites on top, I don't know it, so call it x. On bottom is the hypotenuse, that's 21. So now solve for x. Ditch this, divide by 21. So times both sides by 21, times this by 21, times this by 21. So 21 times the sine of 75, and that is going to equal 20.3. So it's going to reach 20.3 up on the building. Okay, 10 is pretty similar. 10, Katie and Matt are flying kites. String on Katie's kite is 864, and her kite makes a 40-degree angle with the ground. So here's Katie right here. And in her hand, here's where the string starts. So the string from her kite is going to go, and the string is 864. But from the ground, that's going to make an angle of 40 degrees. Okay, let's make a triangle. So let's go down. There's my 90. And what does it want? Determine the altitude of each kite. So Matt's, his string goes out 725 feet, and his kite's 38 degrees. So there's my triangle. They want this piece right here. That's kind of a bad question, because they want to know the altitude of each kite. So right here is the kite. The kite is right here. So how high is this kite off the ground? But the kite off the ground is going to be this distance plus however tall your hand is. So if your hand was like 8 feet above the ground, you'd have to find this, then you'd have to add the 8 feet. So it's kind of a poorly worded question, but we'll just find how tall this is going from the very top just to the bottom of this. So just to his hand where he's holding it. Okay, now 40 is where you're going from. If you're going from 40, this is going to be the opposite, and this is your hypotenuse. So we're same exact thing, you're using sine. So we're going to do the sine of 40 degrees, and that fraction is equal to x over 864. So times both sides by 864, times by 864, 864 times sine of 40. And that, this height right here is 555 feet, 0.37. And I'm not going to do math. Math is the exact same. So label your triangle, figure out which trig you got to use, and then solve for x. Okay, 11. Find the sine of 17 pi over 6. 17 pi over 6, this is in radians, so we got to change it to degrees. So 17 pi over 6, let's times that by 180 over pi. So my pi's cancel. 180 divided by 6, that changes to a 1. And this changes to a 30. So now you got to do 30 times the 17. and 30 times 17 is 510 degrees. So that's more than a circle. So I'm going to minus 360, 510, minus 360. So I need to do the trig on 150 degrees. So here we go. Your initial side starts right here. 150. So that's going to open up to 90. It's going to stop right here. This is 150 degrees. But you're going to do the trig on this angle right here, which is 30 degrees. So always drop down, make a 90, and it's the 30. I'm going to flip it over, this 30. So this is an equilateral triangle. I'm going to make up my own dimensions. 10, 10, 10. But if that's 10, this guy's 5. But this guy happens to be a negative 5 because it's going below. And then this right here is 5 square roots of 3. But it's negative because it's going left. And they want the sine. So the sine is the opposite over the hypotenuse. So if you're looking right here from the 30, the opposite goes straight across. Your opposite is 5. So 5 on top, hypotenuse on bottom, hypotenuse is 10. And that's going to be 1/2. Now the trick on these is you've got to pay attention to the negative signs. Because this one ended up both being positive, but if they would have asked you for this, make sure you include the negative. So if they would have wanted cosine, make sure you include the negative with it. Count 12, 7 pi over 4. Same thing. 7 pi over 4 times that by 180 over pi. That divides 180 divided by 4 is 45, and 45 times 7 is 315. 315 degrees. So 315 is not quite a full circle, but it's pretty close. So this is where we start. Now we open up 180, 90, 180, 270, 315 is going to be somewhere right here. So this angle is a 315 degree angle. But we're going to do the trig on this, the reference angle. So go up, make a 90, and that is a 45 degree. Okay, and a 45 is half of a square. So in a square, there's your square. All the sides are the same. So 10, that's negative 10, that's 10, that's negative 10. This hypotenuse is 10 square roots of 2. And they want the cosine. So the cosine from here, this is the opposite, this is the adjacent, this is the hypotenuse. So the cosine, they want the adjacent over the hypotenuse, so they want 10 over 10 square roots of 2. Your 10's divide out, so you got 1 over square root of 2. Can't leave a square root on the bottom, times the bottom by square root of 2, times top by square root of 2. So on top you got square root of 2, and on bottom you got square root of 4. So you got square root of 2 on top, on bottom you got 2. Okay, last page. How long is it going to take for the minute hand on a clock to go through pi over 3 radians? Change it to degrees. Pi over 3 radians times 180 over pi. That kills that. 3, 180, that's 60 degrees. Okay, on a clock. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So each 5-minute tick is 30 degrees, because if I go from here and I rotate down to 15 minutes, that is 90 degrees. So that means this sliver is 30 degrees, this sliver is 30 degrees, and this sliver is 30 degrees, 30, 60, 90. So every 5 minutes is equal to 30 degrees. So if I'm going 60 degrees, that's 10 minutes. Number 11. Angle A. Okay, let's make a triangle. This triangle is 1, 2, 3, 4 along the bottom, and 1, 2, 3, 4, 5 along the top. I'm positioning from A, so 5 is the opposite, 4 is the adjacent, and I know I'm going to use trig, opposite and adjacent. I'm using tangent. So the tangent of A equals opposite over adjacent. So if I know the fraction, but I don't know the angle, I can undo the tangent. I can do the inverse tangent on both sides. So the inverse tangent of 5/4 will give me the degree. So press and hold tangent on your calculator. Inverse tangent of 5/4, 5 divided by 4. That is a 51.34 degree angle. And that is it for the trig and logs.